Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation – phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus,
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, A spacecraft launched by the European Space Agency discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place? It might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede, and it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the Moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly. Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us. Or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
A team of intrepid scientists have devised an audacious plan to unravel the mysteries of the universe. Their secret weapon? Computation. The very heartbeat of living systems. But what's that? And how will computational zones help us to find extraterrestrial life? Let's find out. In our universe, there are special places called habitable zones. They hold the key to life as we know it. You see, planets are a bit like picky eaters. They have specific preferences for their conditions. Just as we humans need things to survive, planets need their environments to be just right for life to thrive. So, what's the secret recipe for a habitable zone, you ask? It's all about finding that sweet spot where liquid water can exist. Water, as we know, is the magical elixir of life. Planets love to have it flowing or sloshing around on their surfaces. So, we need to find the perfect balance. If a planet is too close to its star, things get toasty, and water evaporates into a sizzling mist. On the flip side, if a planet is too far away, it becomes an icy wasteland, freezing water solid and turning potential life into popsicles. But within that perfect middle zone, also called the Goldilocks zone, temperatures are just right. That means planets have the perfect conditions for life to potentially take root. For a long time, scientists have been looking for planets in these zones. And as of January 2023, we have found a total of 63 potentially habitable exoplanets. However, a recent study has changed our view of where we should look for life. Gone are the days of restricting our search to mere habitable zones. Oh no, we're thinking big. Get ready for the computational zones. These enchanting realms could house life forms we've never even dreamed of encountering before. But what exactly are these computational zones? Well, let's see. When scientists search for life in the universe, they usually look for things similar to what we have here on Earth. They imagine creatures living on a planet's surface at just the right distance from their star and using water for important chemical reactions. But what if life can be much more diverse and fascinating than that? Imagine life using different liquids instead of water. Picture life hiding deep underground in icy moons. It's even possible that life doesn't need a star at all. And there might be biological systems that are different from our idea of life in general, but still alive in their own unique way. That's why two clever researchers have come up with a new idea. They want to change how we think about the places where life could exist. Instead of focusing on habitable zones, they suggest looking for computational zones. Think of these computational zones as special kitchens, where the secret recipe for life is being prepared. To make this recipe work, we need three key things. First, we need a variety of special ingredients, like different chemicals. Just like a chef needs various spices and flavors to create a delicious dish, life needs different chemicals for its calculations. Second, we need a source of energy, like sunlight or heat from hydrothermal vents. This energy powers the cooking process, just like heat powers a chef's stove. Lastly, we need a dedicated space, like a kitchen counter, where all the calculations can happen. It's the place where the ingredients come together and amazing things start to occur. In our case, it was our solar system and our planet Earth. Basically, computational zones should have three things: some chemicals, source of energy, and space. This makes a pretty wide sample, isn't it? By focusing on computational zones, the researchers believe we have a better chance of finding signs of life. These zones could lead us to amazing discoveries and show us that life in the universe is much more creative and diverse than we ever imagined. And here's the real mind-boggler. This idea also leads us to think about technology. Yes, AI and stuff. Just as we humans create and use technology, could life itself create its own technological marvels? Life could be biological, digital, or even something completely different. Computational zones give us a fresh way of thinking outside the box and get creative. Now here's another twist in all this research. Turns out that life might be much closer than we think, as if in our own solar system. It turns out that the insides of icy moons, like Europa or Enceladus, answer to all these conditions. They're just as fascinating as the surface of rocky planets. It's like realizing that hidden treasure lies right beneath our feet. Europa is Jupiter's icy moon, which is as old as our Earth. It looks like a half sphere with a bright icy appearance, an off-white color with a hint of blue. Mysterious dark lines stretch across the moon, forming patterns. It lacks towering mountains or deep basins, but instead showcases dark ridges, grooves, and long streaks. As you move toward the bottom of the image, Europa fades into darkness, leaving us curious about what lies beyond. But the most important thing about Europa is that it's a fascinating candidate for life. First of all, this moon has liquid water in abundance. Scientists believe that there might be an entire salty ocean beneath its icy surface. There might be twice as much water as all the oceans on Earth combined, but life needs more than just water to exist. It requires certain chemical elements like carbon, hydrogen, oxygen, and so on. They're like the building blocks of life. These elements are found throughout the universe and make up a whopping 98% of living matter on Earth. And Europa is believed to have a lot of all these elements too. Perhaps they were brought there in the distant past after a collision with asteroids and comets. Although it's pretty cool that we found organic molecules on Europa, it doesn't automatically mean they are linked to life. These molecules can be created in non-living processes as well, but they still give us some very important clues. And finally, energy. It's like fuel for life. Just like we need food to keep going, all living things need energy to survive. On Earth, plants get their energy from the sun through a cool process called photosynthesis. Plants turn sunlight into food, and when animals eat those plants, they get energy too. But the kind of life that might live on Europa can't rely on sunlight. Europa is covered in a thick layer of ice, so there's no sunshine reaching its surface. Instead, life on Europa would have to find another way to get energy. And that way is through chemical reactions. Europa's surface gets showered by radiation from Jupiter, which is not so great for living things up there, to say the least. However, this radiation can actually be helpful. It helps to create oxygen and hydrogen in Europa's atmosphere. But that's not all. As Europa orbits around Jupiter, it gets flexed and squeezed by the planet's gravity. This flexing generates heat, just like how bending a paperclip can make it warm. The heat from this process can provide energy for life too. So as you can see, Europa's potential life forms have to get creative. But this little moon still has a very high chance of supporting life. It's a fascinating and mysterious world out there. And Saturn's moon Enceladus is also an exciting place where life could thrive. But detecting this life is no easy task. The moon is covered by a thick ice shell with a super deep ocean beneath. Even here on Earth, that would be a huge challenge, let alone on a moon halfway across the solar system. Enceladus is nothing like Earth, so don't expect to find cows and butterflies there. But it would have its own unique ecosystem. Some organisms that rely on chemical reactions for energy. Although life on Enceladus, if it exists, might be extremely scarce. But regardless, we should keep exploring it. Any findings would be helpful for our future missions. All these new discoveries open new possibilities and fuel our curiosity about life beyond our planet. Who knows what exciting discoveries await us in the vast universe? Let's keep exploring and find out. Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features. But one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These two shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the four. It's comparable in size to the Moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in two ways. The first is through congelation, a rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here. So Mars has 2 moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its suns after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these 2 satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the 2. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time, they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding.
Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night, and suddenly there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon, but then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in 2 from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the Moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the Moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the Moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the Moon. We can blame this on meteorites that fall on the surface. Because the Moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the Moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the Moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the Moon. These places have never seen light, and the water there might be encased in ice. But SOFIA found water on the sunlit surface of the Moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the Moon. But an even more unusual phenomenon is happening there right now. The Moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the Moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the Moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the Moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the Moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the Moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the Moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the Moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true.
We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars? It's just an empty, endless desert. Venus? Only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of superliquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth, and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light-years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars' satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations. So why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution and growth of a technologically advanced civilization. But just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the Moon. One theory of the formation of the Moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the Moon. Then, the Moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.
You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo, there's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. and the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet, different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window. Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the Sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in… Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in a starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
Soon we might start constructing loads of stuff on the Moon. All because India's moon mission has recently detected sulfur near the Moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the Moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the Moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the 4th country to safely land a mission on the Moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the Moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the Moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar-penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the 4th planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero. And that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Look.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was alright did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July, 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February, 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origins satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called Mission Control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all science-y. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.